Database design has multiple steps, and it's a reasonably codified process by now. It's been around for a long time. Parts of it are things that are sort of organizational, that happen in the organization that's trying to represent its information, and parts of it are sort of computer science, and it's an interesting blend of the two. Usually it starts with what's called requirements analysis. You have to figure out what the people who use this database are doing with it. What do they need it for? What are they trying to capture about the real world and store in a database? And that usually is a dialogue with people who are not necessarily technical, but those are the people whose problems you're trying to solve. And very often the content that's in their heads is hard to express, not only because it's hard for them to express, but also because it can actually be hard to sort out in a formal way what is required to model what's going on in the real world. So that's called requirements analysis, and it involves a lot of talking and a lot of translating general ideas about how processes and organizations work into concrete ideas about how to structure data. From requirements analysis, typically we move to conceptual design, and this is a more technical description of what the database is going to store. It's usually done in some high-level description language, often with what's called an entity relationship, or ER model, which is what we'll learn about today. Some programming frameworks also force you to do conceptual design. And when I say force you, I think it's a good thing. They help you do conceptual design. Object relational mappings are popular software packages that help you figure out how program objects in your programs should be captured in a database. So these ORMs are, examples of them are Hibernate in Java, or Ruby on Rails, or Python's Django package. These are all object relational mappings. And they encourage you to program sort of in the same vernacular that we're going to learn today for conceptual design, which is roughly entity relationship models. The next step below conceptual design is logical design. And here we translate an entity relationship diagram, which is really a visual representation of your data, into a database management system data model, which is a strict relational representation of the data. ORMs often do this for you under the covers inside of a programmatic interface. And in fact, logical design can, to a degree, be automated. And we'll learn about that in subsequent lectures. Beyond logical design, then, you get a schema, and you need to refine that schema to make sure that it's consistent and normalized. And this is a process we will be learning about in a subsequent lecture as well. Below that, you have to take your logical schema and decide on its physical design. So what indexes do you need to build? How do you want to spread your data across multiple disks, for example, if you're in a parallel environment? And this is what's called physical design. And we've gotten a flavor of this from our discussions of query processing and parallelization. Finally, security design is an important part of any database deployment. You have to figure out access control for who accesses what, how they access it, and what they're exactly allowed to see. And as we'll see in this lecture, that can actually be a bit subtle and more interesting and rich than you get in traditional file-based systems. Today we're going to focus, though, on conceptual design for the most part, which is done here at the entity relationship level.